Hey, how's it going? I'm back. Yesterday I left off trying to just get a test image with the analog side of things done on the mod. So we have the RGB lines connected, and we have a ground, obviously. We have the blanking pin here, but we couldn't get any image out, and I was supposing we could get a washed out image, something like that, but after reading some of the other mod documentations that Immerhacks has here, I realized no, you're not going to be able to get a test image unless I would take out all of the resistors and all of that, so that we would be basically overflowing the voltage for the RGB pins. So in a way, it's a good thing that we didn't get the test image going. So today after thinking about this thing all night, I woke up early and started working on a printed case for attaching the BNC connectors and the switch for the mod. Did some testing on the grill and got to a design that I like. It's currently being printed. Maybe I can show it to you guys in here. Yeah, it's being currently printed. It's going to take about an hour, something like that. So hopefully it's going to be ready once we're ready to use it. And also had to take the dust off my Arduino stuff, and realized that two things actually. So we're going to need an Arduino here, right? Because we're going to mangle the I2C bus communications so that we can actually get RGB. Let's zoom in. I realized two things. Pro Minis, this is an Arduino Pro Mini, I'm not sure, Minimo, whatever. Don't have like a programming header per se, or an FTDI, I think it's the chip, FTDI chip, so you got USB connectivity or anything like that. So you need another device in order to program it. And I had a FTDI and a relic of the past, and tiny ISP USB, tiny USB, something like that. An ISP, basically, programmer. And none of those worked because one of them, the FTDI, was 3.3 volts, and that might have worked, but since this is a 5-volt Arduino, I think the minimum voltage for Arduinos on 5 volts is around 3.8, 3.9. So it might have worked, but it might have also like corrupted the flash and left us with more problems. So I remember that you can do a trick here, and you can have a Arduino, take the actual chip off the header here, and just wire the ground and your voltage, the reset pin, and the TX and RX directly to your other Arduino. And you can program it that way, so you're piggybacking basically off the main Arduino board. So yeah, that's a tip for you if you want to use a Pro Mini, which is really nice because it's really small. You're going to need a programmer of some kind, or an Arduino that you can take the chip off. You might be able to do it without taking the chip off, and maybe pressing the reset button just as you start programming, something like that. Maybe I remember people doing that, but not sure how well will that work. Anyways, gonna zoom out a little bit here. What I'm going to do, I'm going to start by getting the software that we need in the Arduino, which is the I2C communications mangler / sniffer / proxy / whatever you want to call it, that Immerhax did. And also, he was really nice yesterday. I realized that he was on a Discord chat with me, and he answered a couple of questions, so thank you a lot for that. Oh yeah, one of the things that he said is that the caps here on the on the schematic, I'm blanking out on names. So the 0.1 microfarad or 100 nanofarad capacitor is there to filter DC. And basically the value is important. It might have worked with the 0.01 microfarads that I had in there that I extracted from the board, but the value is important. So I went to my old like reclaim parts bin and found 300 nanofarad capacitors, film capacitors in there, and I switched them. So that's the one change I made while you weren't looking at me. And I could have used the tantalum capacitors that I had here, but to be honest, for analog signals like audio or video, you don't want to use tantalum or ceramic. It's going to work, but it might introduce some degradation to the signal. And also I learned that tantalum capacitors are made from a very contentious source that is really like not great for both humanitarian reasons and like sustainability reasons, ecological reasons. So that's another reason not to use tantalum capacitors unless you really need them. Plus they're not cheap. So cool. I'm going to switch to my desktop screen here. Where is this? There you go. Cool. So we're gonna do the Arduino side of things. Gonna make sure that my screen is showing properly in there. Yeah, my screen is showing properly. Cool. So I know that some people like on the CRT like hobby business craze. I'm not sure what to call it. Might know some about analog electronics, or a lot about analog electronics, but I know that there's a good number of people that have no idea or little idea about how like Arduino and GitHub and all of that stuff works, and that makes sense because you don't need to use them too much for CRTs, right? Unless you're going for something special. So I wanted to show how to do this thing in case someone needs this. So you need to go to the link there in Immerhack's build guide. You're going to come to this GitHub repo, and you have two options. If you know how to use Git and Git help, you can just clone and you'll be fine by yourself. But if you're not sure what you're doing in here, you can come here and download the zip, which is going to basically download these two files as a zip. And you are going to want to use this file in here, right? So this is actually the other option. You just come here, and since it's just one file, you can just copy and paste it. You copy all of the source code for this file, and we go to the Arduino IDE, which you can just download and install, or if you're in Windows, you can get from the Windows Store. It's really easy, nothing fancy. So you come here and you can just say file new and paste all of that code in. Going to close this other one, and you can call it whatever you want, to be honest, but just to be, because I'm a control freak, I'm just going to copy and paste the name here and save this file. So I'm going to go save. It's going to ask, and I'm just going to tell it this is the name. It really doesn't matter what name you give it, but you can just use whatever you want, basically. So that's step number one. Step number two is you have to make sure that you have, and this is going to look a little bit freaky for a little bit, so sorry about that, but where is there's a library name that you need to make sure that you have in here. Where is it? I think it's close to the, yeah, here is it. So you need to make sure that you have the this library installed in the Arduino IDE, and it's really easy to do. You go to Sketch, Include Library, Manage Libraries, and you have to wait a little bit until this window shows up, and until it updates all of the list of libraries and blah blah blah. And you just write down the name, Soft I2C Master, and it's going to show up, and you say install, and that's it. That's all you need to do, at least for installing the library, right? So now you can go to the board and select your board. So if you're using an Arduino Pro or Pro Mini, again, not sure what to pronounce that like, just choose the board that you'll be using. You'll be burning the flash to, and select the processor that you'll be using. I'm using a 5 volts 16 megahertz version of the Pro Mini, and select the port. And normally this is going to show up like with a name, so it's easy to know what you are using, right? And from there you can just come here and say upload. You can go verified and then upload, whatever. So it's going to take some time to compile this sketch or this source code, and then it's going to start flashing the Arduino. And once it's done, it's going to say done uploading, and it's going to give you a message like this one with some details, and that is it. That's good to go. So like you can see, it's really easy once you know what you're doing. So don't be afraid of these type of mods where you're going to need some kind of Arduino or something like that. It's normally really easy once you know the basic steps for just getting the libraries, getting the source code, and connecting your Arduino, burning the software into it, and that's it. Cool. So hopefully that helped someone. Oh shit, I almost clicked stop streaming. Lol. So now I'm going to take these out so we can get back to the camera. And we're gonna keep going with the mod. So now I can just disconnect just plug it out, and I can take the Pro Mini off, disconnect the wires from the programmer, and I'm going to put it on my bag, my Arduino bag, so I can use it again sometime when I need it. So another thing that I need to do with the Pro Mini is I need to solder a couple capacitors, and also I soldered this header here so I could just plug the cables to program it. So I'm going to take this off, and I'm going to solder a couple resistors in there. So again, gonna put it in here. Gonna get it in focus so you can see what I'm doing. That looks fine, I think. Yeah, that looks fine. Cool. Gotta turn on my soldering iron, and you look in here. We get recommended a couple resistors from 2.7K to 4.7K, from D4 to and D5 to BCC. So I have here some 4.7K resistors, and I'm going to do just that. And also I'm going to take out the header, but I also, while my iron heats up, I need to locate the D4 and D5 pins. So if we're looking at it like this, oh, this is actually the other way around. Okay, so I'll need to check what is BCC in here. So I have PCC there. And D4 and D5, I'm guessing are these two in here. So 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, those look like D1. Going to show you here. So if you look at the top here, here we have PCC, and here we have 4 and 5, which I'm assuming there are D4 and 5 since the digital pins normally don't get the letter denomination on the PCB, but we can check just to make sure. Okay, so now we can get back here. And I'm just going to quickly desolder the headers, and then I'm going to check if the pins are correct. So just doing the quick saki, getting all of that solder out. Hopefully it will be easy to get it out. Just as I said that one pin doesn't wanna. That's okay. Let's see if I can just put my soldering iron like this. Oh crap, no, it's too hot. Okay. Yeah, that looks better. Okay, cool. So 2 pins don't want to get desoldered, so I'm going to put more solder in. And yeah, those really don't want to. Okay, that's better. Yeah, that's better. Okay, so hopefully we can just push it out now. It's really hot. I'm going to try to push it out with my table. Nope. Not going to force it, so maybe where are my pliers? Okay, cool. I'm trying to see how can I get a good grip on the, and it's stable enough. Okay, that should be good enough. And from here, I can just get my soldering iron and try to heat it up while I pull. I think it budged. Okay, some of it is coming out, but I think it's just a plastic part. Oh crap. Okay. No, actually everything is coming out from that side, but not from this side. It's moving though, so I think okay, yeah, little by little. It's coming out. It's coming up, it's coming up, it's coming up. Not there yet. It's there. Okay. There you go. Coolio. So now just going to check the pins, make sure that we're soldering the right thing. So I need to find the page from Amazon that I got this from. Hopefully they will have a pin out there. If not, I will have to trust some other pinout somewhere. So I'm looking for... What am I looking for? For uns. Hopefully I don't have anything too compromising here. Okay. I don't think they have a pin out. Yeah. So I'm just gonna have to try some other pin out. Yeah, no pinouts. So let's just look for Pro. Crap, that's not Marino Pro Mini pinout. Yeah, that looks like the one we have, hopefully. Okay. It looks a little bit like the one we have, so hopefully it's going to work. Just in case. So this picture is garbage. You can see crap. So let's see, we have DTR, TXO, RXI, BCC and ground, which I think are correct. Yeah, 2 grounds at the end. Then we have raw on this side, raw, ground, reset, BCC. In this board it says ACC for some reason, I guess analog voltage, but should be the same, I think. Then we have the ADC lines, some digital pins. Yeah, I think this is the correct pin out. Yeah, and then we're ground reset, RXI, TXO. Yeah. Yeah. This looks right. So that's good. Okay, so it says wire from 291 goes to A5, the analog, A4, and the other paths 291 go to D5 and D4. Okay. So what I'm going to do, since we're going to also solder wires on that same pins, I'm going to first solder the BCC on the underside. So like this. There we go. You can clip the lead. And oh crap, I did a dumb thing. I left the resistor up. Okay, that's fine. I can just move it a little bit. So going to see, okay, I'm going to use the other one so I can get a longer lead in here. Okay, stay there. Like that. Cool. So going to 5 and 4. So I'm not going to solder the other lead just now, just yet. But what I'm going to do is I'm going to solder this one to the other resistor to the same lead here. So this should be easy enough with just a little bit of thinning. Did I go over here? Or here? I think here probably is going to be better. Okay, made sure that the leads were touching so we get a good connection in there. Although resistance in this particular place wouldn't matter too much because we're just pulling up that those D4 and D5 pins, digital pins, so it doesn't really matter that much. But still. Okay, cool. So from here, I'm gonna need some cables. To connect, I'm going to need 4 cables, and I think I'm going to use the same color scheme. That's on the picture. So green and yellow. Also, gonna get those onto pin 4 and 5. So I'm going to make 4. Let's see. So 291 is going to be SCL, 2S5, A5, and A4, and D4 and D5. Okay, that makes sense. So the 5s are going to be yellow, let's say. One little hair got out. One little strand of copper wire. Okay. Oh crap. I slipped. I slipped from the hole. Come on. Get in. Don't make me go get the saki. Yep. Okay. So now that wire is too fat and thin, so I'm gonna make a new point here. Okay, now staying there while I get the solder in. Oh, you cannot see, crap. Sorry about that. I just looked at my screen and noticed that you can't see, crap. Okay. Cool. So 5 to yellow. Green to 4. I should actually do it like this so you guys can see better. Okay, that looks good. Flip it around. just gonna solder on those same blobs in there. I will have to kind of hold the cables down. Maybe I can just do the hands here to hold the cables so I don't burn myself. So let's do it like this. Let's push them up. That should be good. Crap. Wanted to use my nail, but instead I use my fleshy thumb. Yeah, just using my nails to push the leads in there, so I make sure that the cables and the leads are making contact, actual contact, and it's not just solder. I think I need a little bit more solder here. Okay, that's better. That's much better. Cool. So now I can trim the leads. And I need to solder the other side of the cables. So how much length do I actually need in here? So I'm going from R291. R291, where the heck is that? See, R292 and R2, okay, these two here. Yeah. So from here, you can put it around here and have it there. Okay, so maybe something like this. Oh, like this. Yeah, that should be more than enough. And strip in some more wire. By the way, oh yeah, let's change the music. Let's try this one. Yeah, this is good. How's the printing going? Oh, it looks good. So I'm gonna show you the printing here. That's looking good. 59%. get back to 4 and 5. Pins 4 and 5. Okay, so 4 and 5 we already have. We need A4 and A5 now. Okay, so I think I need to trim a little bit here. And 4 is green. So oh, this is nice. This sounds a little bit like Sade, you know? This is no ordinary love. Sounds a little bit like Sade. Cool. All good, all good. So we are also going to need to solder in 1, 2, 3, 4, 1, 2, 3, 4. We're going to need power and ground. Red and black. How much are we going to use? That's a little bit, so this is probably enough. I need water. Good stuff. Okay. So so this is an important part. We're going to take the boards DC voltage. There's 9 volts around here in many places, so we're going to take that and we're going to feed it into the Arduino's raw input, which is going to take it and regulate it to 5 volts for the Arduino to use. And that way, it's not it's not only the Arduino is not only powered, but it also starts up with the monitor itself. Immer hacks guide here has a little bit of explanation why that is important, so that the monitor doesn't lock up because of the Arduino starting up too late. But the important part is, yes, we're pushing 9 volts into the Arduino, which is completely fine because the regulator in there is good up to 12 volts. So no issues at all pushing in 9 volts there. Good. And ground. All good. You know what? Originally, I was going to go to the flea market today here in Chile, and I was going to look for some CRTs and maybe some nice retro gaming stuff or something like that. But I didn't think this mod, or rather getting the stream working and all of that, would take so long. So today is going to be, I think it's going to be pretty much just finishing up this mod and maybe playing some games on the monitor so we can enjoy our work. But next week I will definitely go to the flea market, which here in Chile we call Mercado Persa, which is like Persian market. For some reason we call it that. Some people say it's because it started out as people just putting rocks in the floor and just displaying the stuff that they had to sell. So Persia, rugs, Persian market, whatever, right? Not sure if that might sound a little bit racist to people outside of Chile, but here, like, it's not. So, I actually got my big consumer set from there. My Sony 29KB 310. So that's like, they say it's like the holy grail of consumer sets, and I kind of have to agree. It's a really nice aperture grill set, and with the RGB mod, it looks amazing. It looks properly amazing. It obviously doesn't have the resolution or the preciseness of a PBM, especially at 29 inches. But it does look amazing, and I would say that the best part of it is the sound. It has a really nice sound system integrated on it. It has a woofer inside, and the speakers are also really good. So definitely pick it up if you can, because it's really heavy. And if it's cheap enough, it cost me like 30 bucks. So yeah, I immediately had to buy it. It was a pain to get it here. I don't have a car. I don't like driving. So I mainly move around in bicycles or public transportation. So I tried to get an Uber to pick me up with a 29-inch CRT TV, but they didn't want. to deal with that at all. Even if I told them, hey, I'm going to give you a really good tip, they didn't want anything to do with that. So, and that's okay, like I understand. So I had to call my dad and tell him, hey dad, I will get you out to lunch, a really nice lunch or dinner, if you help me get this huge CRT to my home. And he was really nice. He obliged. He helped me out. So I'm really thankful for that. My back was kind of broken after carrying that CRT, but it was worth it. Cool. I think the Arduino part is ready. All good to go. So, did I solder everything? Yeah, I'm just going to show you here. So, here's the back side. So these pins, these digital pins, are pulled up high with these 4.7K resistors. And on the other side, we have the ins and outs for the mangling, and we have the raw on the ground. So now we get our video board back. Actually, I'm going to get the blanking from the Arduino also, I think. So I'm going to use, because I don't want to, I think I could just pass like 9 bolts into there, but yeah, that's yeah, I'm just going to pass the 9 bolts and whatever. Like, I'm just being extra careful. Or rather, I was being extra careful, like if I can pass just 5 bolts, because it just needs like a bolt to blank. Like, it doesn't need more than 1 bolt, really. Anything past 1 bolt is fine. But I'm not sure about the limit of it. But since the chip itself works on 9 bolts, I think it should be fine to pass 9 bolts to blanking. I've done that in other consumer sets, but you know, this is more of a PBM thing, so I want to be more careful, but I think this should be fine. Okay, let's put the video board in. Okay, so I'm trying to get it on camera. It's hard to. Okay, there you go. Cool. So now we need to take these resistors out. Let's get some lighting, better lighting here. Maybe like this. Yeah, that is better. Okay. So this one need to go is 291 and 292, because that is the place we're going to hook onto to mangle the I2C signal so that RGB is actually displayed on the monitor. So same thing as yesterday, I'm just going to get some solder here and push the resistor to the side. I'm going to try to save the resistor just in case, but it's probably not an important thing to do, really. There we go. Okay. Cool. So now we have these two pads. Making sure they aren't bridged, and still think the lighting is not great. Okay, that is better, I think. Cool. So we're looking at here, these two. So, let's see. What wire goes where? Okay, so okay. So R91 is going to 5A5. So that is the input, I think. So here I should solder the outputs first, I think. So like this, maybe. Oh crap. Okay, so 91 goes to 5. Hey, look at that. They fit in the right way. A5 and R92 is going to A4. Cool. And yeah. Away from the jungle. Just making sure that I'm getting the inputs and outputs right. Okay, so quickly going to tin these wires. In a quick tinning. So the digital pins are going to be the outputs. And since I need to get to those from there, I just want to have a look. Okay, so yeah. I'm going to mount mine like this. So something like that. So yeah, cool. Yeah, I like that. Should work. Okay. So how do I do this without covering the picture for you guys? Yeah, that is going to be hard to do without... No. Maybe if I bring it here and I do it like this, just a second, trying to... Okay. Okay, that's good. Okay, so 91 goes to 5. Good. 92 goes to a... Oh, I'm doing it the... no, I'm doing it the right way. Like you can see, I kind of double, triple, quadruple check everything. Okay, it's a mess. Kind of frayed out the strands from the cable, so I'm trying to push those strands in again so that they don't short crap. Okay, that looks good. But I'm just making sure that I'm not shorting the other pin that is close to that cable. I'm going to move it around a little bit just to make sure. Come on. There you go. That's much better. Cool. Now let's go for the inputs. So 91 to D5. Sorry, it's the other way around. 91 to A5, which is So I need to flip them like this, yeah. Okay, this should be a little bit easier, I think. That's good. Barely in picture, but that's good. Okay. Now, gonna get raw and ground. C509. We can get 9 volts from many places, but I'm just going to use this one. Because he already found a good place, so why change it? C509 there. Okay, so that plane is plus 9 volts, right? So just getting my multi-tester, sorry, my tester out. So now this one is plus 9 volts. That one is also plus 9. Okay, so I'm going to use that pad. Okay, so that might actually have been a little bit too short. Unless... that is fine. No, this is hard to do like this. My cable is too short. This is really hard to do in camera because my soldering iron cable doesn't really reach, and I'm doing it in a very uncomfortable position, like in the back of a Volkswagen or something. Okay, I think I got it. Yes. Okay, just gonna make sure that is connected properly. Yep. Ground. We need ground. Well, that is pretty easy, to be honest. So where did around there? So near to C401. C401, I see it. Okay. Yeah, that's a big ground plane, so I can use whatever from there. So let's see. This is going to go like this. And this ground, I can just attach it in here. Yeah, that should work. Oh, I'm covering up everything. Yeah, I'm going to cover this up, but I don't think this is going to be too much something that interesting. It's just I'm going to the ground plane. That's pretty easy to do. Come on. Yeah, I need to blow that point. Oh, good. Oh, good. Oh, good. So, we are close to finishing this. Last thing I need to do is, on this board, I need to get 9 bolts, wire it up to, you know what, I can just do the quick thing here just to test, and then I'm going to wire up to the switch. I don't need to do the switch right now. So just gonna get some 9 bolts on somewhere. Can get it from there. From C509, just to the side of it, there's a point. So that looks like a good hookup point. I'm going to use that. So just use this point here, which has 9 bolts, and run it to the B blanking pin in here, which is RGB Ys, something like that on the manual. This one here, pin 22, which is analog YS or Ys, or it's probably Luma. No, it shouldn't be Luma. Why they call it Ys? Whatever. That's the blanking pin. So I think we should be ready to test this. I think. Let me see if I'm missing anything. Yeah, I think we're ready. Cool. I'm going to move some crap around, and we're going to test this. Again, zoom out. Where's my zoom? Going to take my mic off for a little bit. So I don't tug it around. Actually, I'm going to use some BHB tape from 3M to glue the Pro Mini to that board in an insulated way. Oh crap. Who did this? Who thought gluing the tape to the tape would it be a good idea? I can tell you it wasn't me. For you. Might have been my brother. Oh crap, this is really glued. This tape is great. Is basically very firm and resistant mounting tape, and it's also very resistant to high temperatures. I bought it to build my boron 3D printer. You need to glue some stuff down that is going to be high temperature, and it's also non-conductive, so it's great when you want to glue down electronics to places that might have some conductive traces or stuff like that. It's not cheap, definitely it's not cheap, but it's great, and you can reutilize it like glue and glue. But obviously it's not that great when you glue it to itself. I'm gonna get a razor blade here. I have to get this out. It's kind of hard to cut actually, so please get out. I think that's good as I'm going to get right now. We'll have to deal with it as I go. Anyway, some of the tape here. It's pretty used up. I will need new tape. Scissors. So this should be enough. I'm actually going to put this in half. It's also this tape is also thick, so it rises. It can act as spacing as well. It's also foamy, so it's really cushioning for your electronics, so they can slip well. Just notice it's the same shit on the other side. Oh my god, why did you do this? Brother! You have failed me. Oh, whatever. Well, let's not deal with this right now. But let's bring this a little bit. One of the other nice things about this tape is that it takes a little bit of time to get really well glued, so you can move it, you can work with it for a little bit. It's not going to instantly like glue to the surfaces. Yes, what I want to do, should I? Yeah, I should not set it like that. Oh, the resistors are in the way, so I'm going to need a second layer of this, actually. So. That. If you don't have tape like this, you can just whatever, mounting tape or hot glue. I don't like hot glue, so I'm not using hot glue. But you can use whatever you want, really. Yeah, so there you go. And now, for the main event, we can plug this in. There we go, nice click. I'm going to put my microphone on my cap. We got the nice click in there. We have the cables. This looks good, this looks good. We need to ground and plug this one. There you go. And we need to ground this. There we go. So now, let's flip the monitor so you guys can see the screen. Okay, so anode cap is in. Going to do this. Anode cap is in. Yeah, it's. This is plugged. This is grounded. We don't need the speaker right now. Card is in. Cool. Gonna get the rest of the stuff in here. is my other thingy? I need my other BNC to RCA adapter. I'll be back in a minute. It's my BNC! What the fuck? I had it. The hell? Do any of you guys have a BNC to RCA adapter? I had it in the cable, and now it's not there. And I'm sure I had more, but I can't find them. Oh, on the good side of things, the box that I'm going to use to house this in is ready. So that looks great. It's going to go in the back like that. Yeah, like this. Come on. So now I just have to find the BNC connector. I have it in my pocket. Nope. Holy crap. my BNC, dude? Where's my BNC? I know what it is. Yeah. Found it. I left it yesterday after not being able to get a test image. I wanted to make sure that the monitor was working. So I use my PS3 to get a composite signal in, and it works. So that's where I put my other BNC connector. Found it. Cool. Okay. Everything looks good. Let's hope nothing blows up. So now I need the power cable for the monitor, and we should be able to test this. Crossing my fingers. Hey, it's working! Woo! Beautiful. Nice. Those are nice colors. So, yeah, that is without the sync. That is with the sync. Oh, and we still have menu, yeah, because it's getting the digital. It has 2 inputs. Nice. Okay, cool. So we don't even have to worry about maxing. That's awesome. This is fucking awesome. Thank you, Immerhex, for the guide. You can see there, lighting up like it should. The blanking is working like that. Everything looks great. Let's see if we can get the 240p thingy working. Where is my controller? What should we use? Okay. Crap, I don't think I have I don't think I have the any ROMs in here. Because it's my system is all connected to Yeah, it's all connected to my RetroNAS setup, and right now it's not. So do I have some GBA maybe? Nope. Well, I wouldn't be able to. Need to go to the GBA. Is it me or is it a little bit too green? Yeah. Okay. So let's go and call reboot. Yeah, it's very green. Why is it so green? Huh. Maybe some resistor was wrong, or is the soldering point there is wrong? Or am I going... It's... I can't tell if it's too green or... I wish I could... Can we cycle the... I just want to change the background. Who is... I should just get some the 240p test suite in there. Okay, so let's turn this off. Now I need to go and get the SD card reader. Get the card. Put it in the reader. Okay. Let's try to get the 240p suite without electrocuting myself. Yes. Yep. 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 So we have the let's copy this into the folder. Okay, let's take the part out. Good. Ooh. Okay, let's turn the mixture on. Let's turn the monitor on. Yeah, I feel like it's super green. It's sharp, but shit do be green. Yeah, it's super green. I don't know what's going on. Okay, so test patterns, color bars. It's kind of green. I'm not sure if this is like a calibration issue, or is the so red looks good, green looks green, blue looks blue, white looks greenish. So this might be a color calibration problem. I might recheck the Oh, for green to overpower the other colors, that would mean that the voltages going through the input circuit with the terminations there aren't is going to be higher on the green channel. So I can check that. Green do look green, blue do look blue, white looks green. Oh, not that color system. Let's go to NTSC. Does that make any difference? Not really. Yeah, that doesn't change anything. I think I will need to just go and calibrate this, because I think it's not like it's 100% green on the white, but it's greenish white. So that might either be some kind of voltage issue going in with the input circuit, or it might just be a calibration issue on the monitor. Not 100% sure, so I will need to test that. Aside from that, I don't think there's much else I can show you. Let me think, because the only thing that I still need to do is basically get the shield back on the board. So getting this thing soldered back on the board, and checking the circuit to make sure that all the resistors are fine and the soldering is fine. And from there, just putting the grill on with the 3D printed thing and the circuit. Sorry, the inputs in here with the switch. So maybe I can show you how I'm going to do the switch. But to be honest, what's from here, it's not that interesting. So not sure if I need to stream that. But it's basically I'm going to be using this kind of switch. So 3 poles, 1, 2, 3, 4 poles, and a 3-way. You could also have a 2-way throw, so that you can basically cut all of the lines together. So I'm going to get RGB and the blanking on the center. This is common. And for one side, I'm going to connect to the inputs. So this going to be just this one. So the inputs are going to go to one side of the switch. So let's say here, the top row, plus the blanking, which is the white cable in here I put in. Right now it's always blanking, so it's always doing the RGB thing. I'm going to also solder those 4 things in here. On the center, it's going to be on these cables here, so RGB plus blanking going into the board, and the other side is going to be connected to nothing. So when I flip the switch to one side, all of the inputs are going to go into the board, and when I flip it to the other side, nothing is going to go into the board. Those inputs are not going to go into the board. That way you can turn the RGB on and off. So you can just connect some other composite source in, and you'll be able to use it like that without the RGB, right? But that's the basic idea. And that part, so the switch, I can't get the thingy out here. Why can't I get, oh, the switch is going to go in here like that, and the inputs are going to go like this in here, right? So like that. And I'm going to use the one of the inputs as the syncing, because you're going to be using one of the inputs as sync, right? And also we don't have to put more extra stuff on the back of the monitor. And this is going to this shell here that I made. You will need, or if you want to do it, I will put this file up if you want to print it. This attaches to these two screws in here, so you don't have to drill or make any new holes in the backboard, back plate, I guess. So it goes like that with two 20 millimeters M3 bolts, and some washers and some nuts on the back, so that you can hold those together, and that should be good. That should be it. So I'm going to finish that off stream, I think, because the rest of this thing is just cleanup and pretty boring. We already got the picture going. And I'm going to post a picture of how it looks. I don't know, around on the Discord servers, probably, and on my Twitter, which is same thing, but on Twitter, like @phosphor_Blu-ray. And yeah, that's it. Thank you again to Immerhacks for putting together this awesome guide and just figuring out all of that I2C mangling, and writing the program and sharing it with all of us. This is really awesome. Thank you so much for doing that, and taking the time to do a write-up, and explaining what happened and what did you do and all of the steps that you went through. So yeah, that's pretty much it. The finished product is going to be, I'm going to put some pictures, some videos, and you'll be able to see it there, but the mod is working. I'm going to calibrate this monitor and putting it back together, and that's it. So thank you so much to everyone for coming, and I really enjoyed doing this, and I'm happy it worked. And yeah, see you again sometime later. Hey, so a little update. I was seeing that the screen the white was very green, very greenish. So it seems like there's a problem here on the small circuit that we made, the input signal conditioning and termination. There seemed to be an issue in there. So just wanted to show you how I'm debugging this. So if you have the same issue, you can fix it. So I think by now, but there's probably a bad component in there. Probably one of the capacitors. So what you can do is you can get your multimeter, set it for AC voltage, and you can measure the voltages. So right now on the screen I have pure white, with the 240p suite, I set the screen to full white. And if I measure, so I'm going to measure from ground to red, you can see it's about 100 millivolts. So 0.1 volt on the red. On the green, it's also 0.1. But if you go to the blue, which was the green, I just switched them around. So now the screen is really blue. It's 0.2. So on white, all of the voltages should be the same. And as you can see, from the other lines, I'm getting 0.1. And I can get a, here we go, 0.1. But here, I'm getting 0.2. So that makes sense, since I'm seeing, right now I'm seeing a bluish tint, because I swapped the green and the blue around so I could test to see if it was the color, the calibration on the tube, or if it was something in the circuits. So when I switched those around and also switched the input cables around, so the colors were right, I noticed that I got a bluish tint instead of a greenish one. So that means that this circuit right here on the middle has some kind of issue. And I think the solder points are right, but one of the components must be bad. One or more of the components, for that matter. Or it might be a connection. But either way, this is one way to debug any kind of video tinting or those kind of issues. So now what I'm going to do is try to figure out what the problematic component is, or the problematic connection is. Hey, new update. So I went and tested all of the resistors, and their values were right, and they were within tolerance. And I was about to change the capacitor in here, because I said, okay, if it's not the resistors, it's a capacitor, because all of the connections look right. But I decided to do a continuity test just to make sure, and I noticed that in the middle junction here, this voltage divider here wasn't connected. So basically the input to the green signal didn't have the 70 ohm termination, and that caused it to be much higher voltage than it needed to be. Basically, part of the voltage divider wasn't there, right? But the input resistor and the capacitor were connected, so that's why we got signal, but the signal was off. And it looked perfectly. Like if I looked at the solder and the solder job there, it looked perfect. It didn't look wrong at all. But if I looked at it with a 10x monocle, I noticed that there wasn't full contact between the resistor legs. So it wasn't really making contact. So that was the issue. And now white looks white, and it's beautiful. I'm not going to be able to show you right away, because I have the monitor in a weird position, but don't worry, I will film this once it's ready, and I will probably have it on the gaming streams. So also I will post videos and photos. It looks beautiful now that it's working properly. Yeah, that's what happens. So make sure that your connections are touching together. It's not just solder floating around. And also, if you need to debug, go step by step. So make sure that the resistors are the right value. Make sure that your connections are right. And if that doesn't work, you will have to either take out the resistor and test it outside of the circuit, sorry, the capacitors, or just go ahead and change those. So yeah, those are my tips.